Hi, folks. So this video is about understanding what it is to be a solution to a system equation and what you can do with that ordered pair and kind of how it lines up with a graph. Some of the confusion that some students have at this point is based in a limited understanding of what a line is. So we're going to take a look at Desmos a little bit. And what I've put up here is a graph of systems of equations. So here's the equation itself, 3x plus 4y equals 24. That graphs this red line. And y equals 2x minus 5, that graphs this blue line. And Desmos is showing us the intersection point of 4, 3. Now also I have labeled here another point, 3, 1. It's a point on the blue line. It's a point on y equals 2x minus 5, but not a point on the red line, 3x plus 4y equals 24. So I just want to check. Algebraically the 4, 3 value. So let's imagine that you didn't have this graph here. You had these two equations and you used some process, some algebraic process, like either substitution or elimination, either one, doesn't really matter. And you arrived at the solution for 3. And you want to check that solution. You want to make sure that your answer is correct, which you can do on any problem in this chapter. The way to do that isn't to solve the equation some other way, but rather plug in this value into both equations. So 4, 3. So we would plug in a 4 for x, so we would have 3 times 4, plus 4 times, we have 3 for y, equals 24. And then simply do the arithmetic. So 3 times 4 and 3 times 4 is 12 each. So we're just showing that 12 plus 12 equals 24. Okay, so that definitely checks. But it's not enough to check one equation. We have to check the other equation also. So far we've checked the red equation, but let's also check y equals 2x minus 5. So in this case, y equals 2x minus 5. So y is equal to 3, because we take our 3 value out of the ordered pair, equals 2 times 4. There's our x value from the ordered pair, minus 5. And 3 equals, let's see, 2 times 4 is 8, minus 5. And that also checks. All right, so that means that 4, 3 is in fact the solution. All right, because it is a value that appears on both lines. It is a value that it's an ordered pair here that is part of the blue line and part of the red line. So graphically, all those values on each line make each respective equation true. The one point where they have in common makes both equations true. Now, let's say, for example, you were doing this problem and somehow you arrived at the point, the x value of 3. Let's say you got the x value of 3 as being correct. Somehow you made some sign error somewhere, distribution error somewhere, something went wrong, and you wound up with x equals 3. If you took x equals 3 into the second equation and said y equals 2 times 3 minus 5, you would get y equals 6 minus 5, and therefore y equals 1. And you would go ahead and say that, oh, the ordered pair solution is 3, 1. Of course, you'd be incorrect. That would be wrong. But you'd put this down as your answer. Well, if you wanted to check that answer, in order to check it, since you used most recently this equation, you got to at least check the other equation, but it makes sense to check both equations. Well, let's just check it back into the equation we've already used first. So that would be 1 equals 2 times 3 minus 5. So 1 equals 6 minus 5. So that checks. 6 minus 5 is equal to 1. That's good. All right. But we need to check it in both equations. It's got to be checked in the other equation. So in checking in the other equation, we're using the 3x plus 4y equals 24 equation with 3 and 1. So we have 3 times x is 3 in this case, plus 4, make that clear, that wrote strangely, plus 4 from the equation times y, which we're saying is 1, equals 24. Of course, 3 times 3 is 9, plus 4 times 1 is 4, equals 24. That does not check. That does not check. So that means 3 comma 1 is not a solution, is not a solution to the system. Okay. It is a solution to one of the equations of the system. It is a solution to the blue line, but it's not an equation to the entire system. So let me go off of the writing for a second. If I click on this line over here, this the red line, notice that all of these values along here, for example, 8, 0, make the red equation true. If we plug in 8 and 0, 3 times 8 is 24, and 4 times 0 is nothing, so 24 plus nothing equals 24. If we're on the blue line, we come up to a point like this, 2, negative 1. If we plug in 2 for x, 2 times 2 is 4, minus 5, y is negative 1. So there's an infinite number of ordered pair solutions to the blue line and an infinite number of ordered pair solutions to the red line. But when you're solving a system, you're looking to find that common solution to both of them. So when you go to check, you got to check in both equations. All right, to summarize, what I've tried to show here is that checking a solution in both equations confirms that you found the intersection point of two equations. If you can't do that with your solution, you need to go back to your algebraic method and find out where you made a distribution error, a sign error, a substitution error, some math-related error that got you an incorrect answer. It may have gotten you an incorrect answer when you solved for your second variable. It may have gotten an incorrect answer when you solved for your first variable. But if you cannot confirm your ordered pair result in both equations, then you haven't found a solution to the system in general.